The last problem is found on page 61, number 78. The problem 78 is similar with the problem in number 75, where we will find the equations which express its velocity and its distance from the origin as functions of time. So there are two sub-problems in 78. First is, if the particle moves under the influence of a force which is directed toward the origin and is inversely proportional to the square of the distance of the particle from the origin. And the second is, if the particle moves under the influence of force which is directed away from the origin and inversely proportional to the square of the distance of the particle from the origin. So by convention, since force is directed toward the origin, we will have a negative force, and since force in B is directed away from the origin, we will have a positive force. So F is equal to k over x squared, and force is also equal to mass times acceleration. Since we're talking about the particle, we can say that mass is negligible, so we're now left with k over x squared equals acceleration. So in A, it was mentioned that force is directed towards the origin, so we will have a negative acceleration. And acceleration is simply the change in velocity over the change in time equals k over x squared. Multiply both sides by dt, we will get negative dv equals k over x squared dt. Then integrate both sides, so we will get negative v of t is equal to kt over x squared plus c. To get the value of c, we will let t be equal to 0. So this is just equal to, for x squared plus c, so this is equal to v naught equal to negative c. So our new equation would then be v of t is equal to negative kt over x squared minus v naught. So to express distance as a function of time, v of t is simply the change in distance over the change in time equals negative kt over x squared minus v naught. So multiply both sides by dt, we will get dx equals negative kt over x squared minus v naught quantity times dt. Integrate both sides, so this equal to x, dt equal to negative kt squared over 2x squared plus v naught t plus c. So in order to get c, we will let t be equal to 0. So our c is just equal to our x, c is just equal to x naught. So our new equation is this is distance as a function of time in A, and So in A we have v of t equals negative kt over x squared minus v naught, and x of t is equal to negative kt squared over 2x squared minus v naught t minus x naught. So this is our functions in A. And in B, by convention, since force is directed away from the origin, we will just change the negative signs into positive. So v of t is equal to kt over x squared plus v naught, and x of t is equal to kt squared over 2x squared plus v naught t plus x naught.